All right, quick quiz on 4C, 7, 8, and 9 we're asked about. So if a company has $1 million shares outstanding at $10 a share, that would be worth 10 million, just multiplying the two. And if they had, company B had um, 10 million shares at $9, that'd be 90 million. And the third was 100,000 shares at $100 each. That'd be 10 million again, multiplying it. So B is the one that would have the most greatest market capitalization. So that means money in the market. 8. The PE ratio of 75 says that the current price is let's see, current price is 70 times greater than its earnings per share over the year. So the price is 70 times more than the income or earnings. So that's what the P/E stands. Price to earnings ratio. And so that's A. It's what it is. It's not the other ones. And 9, the price you pay for a bond is the face value of 5,000. And if it's going to earn, what was it, 103 points or 103%, that means we're going to get 3% of this more. And 1% of 500 is 50. And so 3% is 150. So the value of the bond would be 5150, which is answer B. Okay. And that said, and the next one says, does it make sense that if you retire, you're going to be retiring soon, so you should put your money into treasuries and bonds and notes? And that does make sense. So when you're getting close to retirement, you want things that are still giving you a return, but very stable so that you can take out your money. And these earn less, but they are very dependable. And that's why you would do that. So it does make sense. Okay, now if you have savings for 5 years at 2.5%, making monthly payments on 100, how much money would you have? So you would pull out the formula for savings that we've been using. And that would be, this is if you put in a big amount and then you're saving. This is if you put in a big amount and have continuous saving. This is compound n times a year. This one is if you're putting in payments monthly, so you put 12 in for the n, and you figure out the amount you have. So that's the formula we're going to do. So we're going to do payment of $100. Our numerator is going to be 1 plus the APR. 2.5% would be 0.025 divided by 12 to the 12 times 5, which is 60, minus 1, close the numerator, divided by, open the denominator, 0.025 divided by 12, close parenthesis. See if I can work that out without making too many mistakes. So that'd be 100, open parenthesis, 1 plus 0.025 divided by 12, close the parenthesis for that, to the 60th power, and then minus 1, close the numerator. So I got numerator opens, and then this part that's to the 60th in parentheses, and then close the numerator, divided by parenthesis 0.025 divided by 12. So if I make monthly payments $100 a month for 60 payments, that would be $6,000, and I would have actually $6,384 and 5 cents. Okay, next one says do the same thing, but we're going to do 24 months, 5%, and monthly payments of $250. $250, so we're putting in more. Last time it was 100, so this is $250. We're doing 1 plus 0.05 over 12 to the 24 months times 12 months in the 24 months total. So that's what I put up here. That's 2 years, so it'd be 12 times 2 we would put up here if we're doing the n times the y. 12 times 2 years, but we can just put 24 months minus 1 divided by 0.05 divided by 12. So I just got to change some numbers in this. So I'll bring that back and go back to the beginning of it. And it's 250 and 0.50, 24, and 0.50, 12, enter. So only in 2 years, only takes 2 years to gain almost as much, $6,296.48. Okay, so now we do it again, but we have one other step to do. This time we're doing $200 a month. We're doing 18 years. So 18 years times 12 months in a year is 216. We want to raise the power Q. So we're going to go back into here, and it's 4.5%. And it's 200, so change that to a 0, 0.45 to 216 over 0.45 divided by 12. And I get that is $66,373.60. Now, 18 years times 12 is 216 times. We're putting in 200, so let's see how much money we actually put in. 216 times 200 is 43,200. That's how much we put into the savings. The rest of this is interest. And so they asked us to compare to the payment total. That's the payment total. And this is the total amount that we got in our savings, which is quite a bit more. 23,000 more. Almost half again as much. It's only 4.5% interest. We want to have $2 million when we retire, so now we're going to try to figure out how big the payment would be. And so we're going to have to figure out, we want the amount at the end to be $2 million. So we're going to figure out the payments. We're going to multiply by the APR over N and divide by this. So we're going to have 2 million times the APR is 0.06 divided by 12 for that denominator times this. And then we're going to divide all this by parenthesis 1 plus the APR 0.06 divided by 12 to the NY, 30 years. 30 times 12 is 360 minus 1. And that would get us the payment. So we'll see how much we have to put away monthly. So we're going to put in 2 million, parenthesis, 0.06 divided by 12, close parenthesis, divided by, and now we got a open parenthesis, 1 plus 0.06 divided by 12, close parenthesis, to the 360 minus 1, close parenthesis. So we need to put in a pretty good size payment, 1991.01 per month. For 30 years, that much each month, and we'd have 2 million in our account. Not many people can afford to put that much in. So the next one says, what have 5 million in 45 years? How much do we have to put in? So I'll just bring this back and put in 5 million. The interest rate now is 0.04, insert a 5, divided by 12, and 0.04, insert a 5. 12 months, and we're 145 years. So that would be, I'll just put it both in here, 45 times 12, or 12 times 45, minus 1. And we'd have to be able to have 5 million when we retire. We'd have to put in 28.63 and 70 cents each month. So I'll write down what I did here. 5 million times 0.045 divided by 12, all divided by parenthesis 1 plus 0.045 divided by 12 to the power of 12 times 45 years minus 1. Okay, and the last problem on this section that we wanted to do, oh, not the last problem, I guess there's several here. We want to have 200,000 for life, just in interest. So first of all, we have to find out how much we'd have to have in the account to be able to pull that much interest. So to do that, how much would have to be in there? So if we just figure out, so we want to run this formula backwards so that its annual interest is 6%. And we'll assume it's compounded monthly because we're going to be figuring out a payment that we're putting in monthly. So we'll just assume this interest rate is applying also for monthly. So how much do we have to have? So we're going to have to turn this formula around. We want to have some principal be put in, and the amount we have at the end that we're going to need will be divided by this 1 plus APR over N to the NY. So we're going to do the amount that we have at the amount we're let's now that's not what I want to do. I want to find out 6% of what would be 6% of what amount would give us 200,000. I don't want to use any formula on this. I'll just make it simple here. So I'm going to go 200,000 divided by 0.06 says I need $3,333,333. 33 cents. So the amount of money I have to have in the account at the end is $3,333,333.33. And when I get there by doing a savings, and so that would be using what we were doing before, we're going to have to figure out the payment. So we're going to have to multiply by APR over N and divide by this to figure out the payment. So the APR they said was going to be 6%, 0.06 divided by 12 over all of this, which is parenthesis 1 plus 0.06 over 12 to the number of years, 40 years, so it's 12 times 40 minus 1. So let's see how much money we would have to have and how big a payment we have to put in monthly, because that would figure out the payment. So this answer times 0.06 divided by 12, and that's in the numerator. Let's put that part in parentheses. Divided by this part, which is parenthesis 1 plus 0.06 divided by 12 to the 12 times 40, not close parenthesis, 12 times 40 down minus 1, close parenthesis. So we would have to put $1,673.79 in monthly for 40 years, and we would have enough to be able to draw $200,000 every year for life. Okay, next one. Great-great-great-grandfather has $300. He puts into stocks, bonds, and cash. So how much are they now? So that was in 1900, and we're going to 2012, they said. So these were the growth rates for those, and so we would just figure out what that would be using this formula for the growth and be doing it once a year, because this was the average annual growth. So we do 300 times 1 plus the APR. For the stocks, it would be 0.063 divided by 1 to the 1 times that's 112 years. So let's see how much the stocks would be worth. 300 parenthesis 1 plus 0.063 divided by 1, which is just that, close parenthesis, to the 112 times 1. Oop, forgot the to the 112. So that $300, if it was put into stocks, would be worth $281,090.96. And if it was put into bonds, it's a lower interest rate. So everything else is the same. The interest rate is now not 6.3, but 20. Enter. So it's same stuff with just a different interest rate. And so we get the bonds only worth $2,756.39. And then the cash is at 0.09. So we now have to go in here and make this not 2%, but 0.09. or 0.9, which is 0.009 in decimal, which is $818.34. Okay. Which would be more using those same, let's see. I think it was using the same, let me look at that, make sure. Yeah, historical terms, same amount of time. It just says, what if you had $10 in stocks? So we would go back to the original, $75 in bonds, or $500 in cash. So this last one was cash. So let's go back here and just change this to 500. And that's 1363.89. And let's go back and do bonds, which was 2%. That was this one. But now we're starting with bonds, $75. 0.75. Let's see how much that comes out to be. 689 10 rounded, and $10 in the one before that. This one, $10, and that comes out to be 9369.70. Okay, so $10 in stocks was worth more than 500 in cash, or 75 in bonds. And then 39 was asked for, but it's about stocks, and I decided not to do those. So that's it for that section.